In the last videos, we have discussed how CNN is better than ANN in case of images, and also we have discussed how CNN got inspired from biology. Now, in this video, what are all the layers involved in CNN that we'll be discussing. The first layer in CNN that we'll be discussing about is the convolutional layer. Followed by convolutional layer, we'll be having a layer which is having some activation function like some ReLU layer. And after ReLU layer, we'll be having the third one, that is the pooling layer. And finally, we'll be having the other layers. Those are called as fully connected layers. Each of these layers are having their own significance. Now let's try to understand what these layers will be doing within this particular CNN. Basically, this convolutional layer will help us to extract out features from the input image. And then we'll be having a ReLU layer which will help us to add some non-linearity. It will be helping us in order to add some non-linearity. So we'll discuss in detail what does that mean later. And then we'll be having pooling layer, which will help us to remove out all the unnecessary information. Okay. Reduction of size simply. And then finally, we'll be having these fully connected layers, which are similar to hidden layers in case of ANN. So you can think these fully connected layers and hidden layers in ANN are the same. So these are all the different layers that are involved in building a convolutional neural network, that is CNN. And as I said, convolutional layer will help us to extract out features. And on the extracted out features, there might be so much of redundant information. That redundant information will be thrown out using pooling layer, which will help us in reducing the size and representing all the important information. And then finally, we'll be having the fully connected layers, which are same as hidden layers. So let's try to see this picture and try to understand what is the process happening on some input image. So whenever we are given some input image, we'll be applying this convolution and ReLU. Combinedly, we can say we are applying both of these. Just ReLU is the activation function. I hope you guys already know what ReLU is. So this activation function will be applied after applying the convolution. So as I said, in this input image, there might be so many important features like ears, and then eyes, and then this nose part. All these are different features, right? So for each of these features, there will be one rectangular box that is called as feature map. Okay. So here, if you observe, there are several rectangular boxes, right? Each of these boxes are called as feature maps, and each feature map is corresponding to one specific feature in the input image. So here you can think this is related to some ear, left ear, and this is related to right ear, and the other one is related to eye, left eye, and the other one is related to right eye. Like that, for all the individual features in this input image, we'll be having such feature maps. After applying convolution, we'll be having all of these feature maps for each of the input image, and how this particular feature maps are getting calculated, maybe we'll discuss in the next video. After getting all of these feature maps, still the size of this is almost equal to the input image. Each box will be having the size as the input image, but each of these are representing only these features. Like in this whole feature map, in this last whole feature map, it will be only having the information about this, and similarly this will be having only information about this one. Like that, all of these feature maps will be carrying information about the respective features, but even though it is carrying very smaller information, also it is, the size is very large, right? So that's why we'll apply pooling, which will reduce the size and represent the same information that these large feature maps are representing. Basically, these three layers, that is convolution, ReLU, pooling, can be applied multiple number of times. So after applying it for multiple number of times, we'll have all the important feature information represented in very small number of feature maps, and on those feature maps we'll be applying flatten. let's say we are having input image. In this input image, as I said, we'll be having a lot of pixel values, right? All these pixel values in general in ANN, if we wanted to build on image, what we'll be doing, we'll be keeping all the values as inputs like x1, x2, x3, so on. Like this is an image of n cross m, then xn cross m. All these values will be sending, right? So that is what we'll be doing in case of flattened. We'll just take all the individual values of the feature map and we'll be feeding it to the ANN. Simply from here, you can think it as simple ANN. And here, instead of calling these as hidden layers, we call them as fully connected layers. So I hope this particular structure of CNN is clear. In the next video, we'll clearly discuss how convolutional layer will work and then how ReLU layer will work. All those details will be seen. So I hope this video is clear for everyone. Thank you everyone. Bye bye.